Okay, so how do we actually graph a quadratic function in factored form completely? So there's a three-step process. First, in step one, let's identify the x-intercepts or the zeros. So remember, in factored form, we can see the factors of the quadratic. So in this case, I'm going to first identify the a value, which is out here in front, and the a value is going to be 1, so I do still want that because that gives me shape. So my a value being 1, and I'm going to have a concave up or opening up parabola, and I'm going to have a minimum value. So all of that falls just from the a value, so it's concave up. So that one number gives me those different blanks filled in. Next, in this first step, to find the x-intercept, you have to let the output, the function y, equal to 0. So the first thing we do here in step 1 is let this equal to 0. And I can just copy everything else down the exact same way. So I'm just copying the function the same way. But now what I can do is find the x-intercepts. So either, for this equation to work, either x minus 5, which is a factor, which is this factor here, either this factor equals to 0, so either that equals to 0, or the other factor, x minus 1, equals to 0. So either x minus 5 is 0 or x minus 1 equals to 0. And by solving these little equations, the results that I get will be my x-intercepts. So that's my first step. So here I can add 5 to both sides. And I get x equals to 5. That's one x-intercept. I can here add 1 to both sides. I get x equals to 1. So I just found my two x-intercepts. And just to be clear, these x-intercepts, they are points. So this x equals to 5 is the x-intercept of 5, 0. And then this x-intercept of 1 is the point 1, 0. So I just found 2 points for my quadratic function. So with that then, step 2 says, let's find our position. Let's identify the h value. And to do this, we're going to find the average of the x-intercepts. So I'm going to simply find the average of what I just found in step 1, my x-intercepts. So for step 2, guys, to find the average of two numbers, you simply add them together and divide by 2. That's all this is. So I'm going to take the 5 that I just found and combine it with the 1 that I just found. And if I divide it by 2, I'm going to find the average of those two numbers. So I get 6 divided by 2, that's 3. And guys, I just found the h value. So I just found the h value of the vertex. That's how that works. So now this is a 3. So I found the h value of the vertex. And then to find the k value, to finish this in step 3, to find the k value, you're going to input what you just found, the h, back into the original problem. So in step 3, I'm going to copy the original problem again. So I'm going to copy exactly as I see it. So I'm going to put all of it there. So f of x equals x minus 5 and x minus 1. So I took this original problem, I copied it over, but left all the x's out. And to find the k value, all I'm going to do is input what I just found here, this 3, into the original question, and I can compute the k value. Now again, notice how this f of 3 is just notation, so the actual work is going to be here on the right hand side of the equation. So 3 minus 5 is minus 2 times 3 minus 1 is positive 2, and I'm left with minus 2 times 2, that's negative 4. So this negative 4 is my k value. So I've just found the vertex as 3 minus 4. Now I have my position. Remember, once you find the vertex, the h value that we found is going to be our line of symmetry. So that's always going to be from the h value. So at x is 3, you can draw your mirror. So there's my symmetry at x is 3. I can also plot my position, which is my vertex of 3, negative 4. That's going to be at 3, negative 4 is here. So I have that point. And then in this example, I have my x-intercepts. So the point 5, 0, or 5 is an x-intercept, and so is 1. Because at this point with this graph, I can do a pretty good sketch, because if I look at it carefully, I've already got my position, the x-intercepts give me pretty good shape, and so I can graph my parabola. Now, to finish this off with the blanks, down here at the bottom I do have two x-intercepts, which I found in the very beginning. So 5 and 1 are my x-intercepts. And then just to make one more point with this question, if I connect to the table, guys, here the vertex is 3, -4. But also know that with the x-intercepts, I can put them here on the table as well. So my last point is, when you have an x-intercept on a table, you can always find it because the y value, the output, is 0. So whenever you have a 0 on a table as the y, the number here under the x will be an x-intercept. So these are our x-intercepts from the table. Again, we can see them whenever the y is equal to 0.